Welcome back to our Chapter 2 Basic Concepts of Derivatives and Their Applications. Now we have Section 2.5 or our lesson number 5, which talks about application of derivatives. The first, this is what we call the optimization, and this is part 1 on this topic. So we have the learning objectives. Number 1, determine when a function is increasing or decreasing over an open interval. Number 2, determine the critical points, if any, for a given function. Then formulate a mathematical equation that models a given verbal problem and apply the first derivative test to determine the maximum or minimum values of the formulated model. So our focus this time is the first two learning objectives: to determine when a function is increasing or decreasing, and to determine the critical points. And for the next lesson, we're going to talk about the two remaining learning objectives. Now, what are our prior knowledge required? Number 1, you must have these skills in doing solutions to algebraic equations and equations involving transcendental functions. Next is solving inequalities, especially the sign chart method. And lastly is basic differentiation formulas, in which it was discussed in the previous lesson. So one of the most important applications of the derivative is in determining instances when a mathematical model of a natural phenomenon or any situation that requires such yields what? A maximum or a minimum. So take note. That is the most important applications of the derivatives when we talk about determining instances. So such process is popularly called optimization. So this is our topic in this lesson, in this section number 5 about optimization. Tapos divided into, I think, 3 to 4 lessons. So that process is called optimization. And in this lesson, the first derivative test will be applied to determine optimality in the context of different fields of study such as economics, biology, and engineering, to name a few. This is a matter of application. When we talk about the first derivative and what we call the test. So recall in our pre-calculus class or subject that as long as the direction of the opening of a parabola, so we know about parabola, right? So it known as the upward or downward opening, we can determine its minimum or maximum value by simply what? Considering the y-coordinate of the vertex. So take note that the vertex has two coordinates, the x and y. Talking about the minimum or maximum, we're going to tell with the y-coordinate of the vertex. Such procedure, however, cannot be similarly applied for polynomial functions of degree 3 or greater. So it can be applied 2 or less, but here 3 or greater, it cannot be similarly applied. Much more to what? To other types of algebraic function, as well as the transcendental function. Thus, it is necessary to devise that will work for all types of functions. So, need nato og usa ka pamaagi nga mo gana sa tanang types sa functions. But before that, or in order for such to materialize, some prerequisite concepts involving the derivatives with properties of graphs needs to be discussed first. So our goal now is to discuss this one by one until we arrive the target on this lesson. So now we have definition 2.5.1. It talks about increasing and decreasing functions. So basic lang. So it talks about increasing and decreasing functions. Now take note, a function f is said to be increasing on an open interval AB if for every numbers x sub 1, x sub 2 is an element of open interval AB. Meaning yung number na si x sub 1 tapos si x sub 2 is a part of the open interval AB. It's an element. And then take notice one, x sub 1 is less than x sub 2. Then f of x sub 1 is less than the f of x sub 2. So, si x sub 1 less than dapat ni x sub 2, tapos ang function ni x sub 1 or the y part, the y coordinate is the same situation, less than function of x sub 2. On the other hand, f is said to be decreasing. Decreasing naman on an open interval AB if for every numbers x sub 1, x sub 2 is an element of AB, open interval AB. And dito sila nagkakaiba because yung x sub 1 is less than x sub 2, which is the same with the first case, the increasing. But yung f of x sub 1 here is greater than f of x sub 2. So, diyan sila nagkakaiba. So, increasing x sub 1 and the equivalent f of x sub 1 is less than x sub 2 and f of x sub 2. For decreasing, yung x sub 1 is less than x sub 2, but yung f of x sub 1 is greater than f of x sub 2. Now, in this illustration, so we have the open interval here. So, this is our A, and this is our B. Take note, the symbol, yan, it talks about open interval. Okay, so x sub 1 and x sub 2 here in this graph is an element of the open interval AB. And then we have the f of x sub 1 and f of x sub 2. Let us analyze in this graph or in this figure, why is it increasing function? So, check na natin, yung open interval AB, yung x sub 1 at x sub 2 is an element of that open interval AB. Tapos here, si x sub 1 is less than x sub 2. And here, x sub 1 also is less than x sub 2. So therefore, this is an increasing function based on the definition of 2.5.1. Now, in the next graph, here we have the open interval AB, right? This is our A, this is our B. And then we have x sub 1 and x sub 2, which are an element of the open interval AB, and the corresponding f of x sub 2, then f of x sub 1. Here is yung x sub 1, f of x sub 1 is greater than f of x sub 2. And here, x sub 1 is less than x sub 2. So based on the definition of 2.5.1, this is a decreasing function. So based on the graph alone, papa-decrease yung graph. Compared to the first figure, yan, papa-increase. So based on the graph alone, we can say or we can tell that the function is increasing or the function is decreasing. Now consider the cubic function. F of x is equal to x cubed. It can verify graphically that this function is increasing, right? So makikita natin na yung graph ay increasing. Say interval 0 and 10 here. 0, open interval, tapos here another 10, open interval 10. So since any pair of values x sub 1 and x sub 2 in 0 and 10 open interval such that see x sub 1 is less than x sub 2 will corresponding aim that will satisfy also that our f of x sub 1 is less than our f of x sub 2. For example, if 1 is our f of is our x sub 1 and 2 is our x sub 2, so the f of x sub 1 here, x sub 1 is 100 and the f of x sub 2 is 200. So yung f of x sub 1 is less than f of x sub 2 and x sub 1 is less than of x sub 2, so the function is increasing. However, a graphical approach in dealing with such problem is often unreliable. So there are some instances that we consider that is unreliable. That's why definition 2.5.1, it requires to test the function for all pairs. Ito yung disadvantage ng definition 2.5.1. You need to test the function of all pairs in the open interval. So lahat ng elements ng open interval, you must test the functions for all pairs. So ang resulta is madaming trabaho na gagawin or it make the task doubly difficult, right? So in order to come up with a method that is not taxing, hindi masyadong maraming gagawin. So the use of derivatives, see, ito yung previous lessons, poses a good alternative. So using this one, hindi na masyadong madaming gagawin. We're going to stick with the theorem. So we have theorem 2.5.1. This theorem talks about the increasing and decreasing functions involving what? Derivatives. So according to the theorem, suppose that a function f is defined over an open interval. Yung open interval rito is AC na, hindi AB. Then f is increasing over open interval AC if the derivative of f of x is greater than 0. For all x, so yung x na isa-substitute natin is an element of the open interval AC. Okay? So pag greater than 0 yung result, automatic increasing ang functions. And decreasing si f over open interval AC if the derivative of x or derivative of f of x or the f prime of x is less than 0. Ito yung opposite ng first case natin. For all x is an element also of open interval AC. So ang pagkakaiba lang, pag greater than 0 yung f prime of x, increasing. Pag less than 0 naman, decreasing. So this is not taxing or madaming gagawin because we just need only one value of x. So here, note that the function is increasing in the intervals open interval negative infinity and a. So this is our a. Saan yung negative infinity? Take note in the x-axis. In this side, patungo doon, is negative infinity. And the other side also, that is positive infinity. So, indicating using the arrows, right? So, we have also b, open interval b, and positive infinity. So, that is increasing. So, here, a, tapos negative infinity. As you observe in the graph, that is increasing, right? Okay, yan, is increasing. And sa b naman, b patungong positive infinity, that is also increasing. Yan. However, the function is decreasing in the interval AB. Yung interval ng A at B, makikita natin sa graph, ito, papa-decrease. That is decreasing function. So, since the tangent lines to the graph of f in this interval are negatively sloped. Okay? In this side, for negative infinity and a, open interval increasing, and also here, open interval b and positive infinity. But the open interval ab, we have here the decreasing. So, let's have now some examples. Determine if the function defined by f of x is equal to x squared plus 2x is, first one is increasing, is it decreasing, or neither increasing nor decreasing over each given interval. Okay, so first one is the open interval negative 3 and negative 1. Next is open interval negative 1 and 5. And plus is open interval negative 3 and 5. So, first is we need to derive the f of x. So, our f of x is equal to x squared plus 2x. So, the derivative of this one is 2x plus 2. So, this one, we're going to use, sa substitute natin, yung value ng x, it must be an element of the open interval. So, in the first one, we have open interval negative 3 and negative 1. So, we may assign x is equal to negative 2. Since negative 2 is an element of open interval negative 3 and negative 1. So, substitute lang. Ayan. F prime of negative 2 is equal to 2 times negative 2 plus 2. So, what's the result? This is negative 4 plus 2. The answer is negative 2. Okay? So, take note that negative 2 is less than 0. So, according to our theorem, pag less than ng 0, that is decreasing. So, this is decreasing. Now, for the next example, open interval negative 1 and b, the same process, we need to find the derivative of the function, the f of x. So, since we have the same f of x, so the same also is the derivative of that, 2x plus 2. Now, let's find our x in between negative 1 and 5. So, we may choose 1 siguro. So, you may choose 0, 1, 2, 3, or 4. So, I choose 1. F prime of 1 is equal to 2 times 1 plus 2. The answer is 2 times 1 is 2 plus 2, 4. And 4 is greater than 0. Therefore, in this one, that is increasing because it is greater than 0. See? Napakadali lang to determine if it is increasing or decreasing using our theorem 2.5.1 compared to the definition 2.5.1. Now, for letter C, the open interval negative 3 and 5, take note that in this third open interval, from our first open interval, yung negative 3 and negative 1. And then, the second one is negative 1 and 5. The third one is negative 3 and 5. So, from the first one, we have negative 3 and we have 5. So, galing lang sila dun. And the common here is negative 1. Okay? So, that is the union. So, this open interval is the result of the union of this one. Okay? But the problem here is pag negative, open interval negative 3 at negative 1, that is decreasing based on our result, right? And then negative 1 and 5, that is increasing. Now, how we're going to determine negative 3 and 5? If we're going to substitute x between this one, negative 3 and negative 1, the result is decreasing. Diba? Since negative 3 and 5, you can choose their elements. So you have negative 2, negative 1, 0, 1, 2, 3, 4. If you are going to choose negative 2, you got decreasing. Diba? If you are going to choose 0, 1, 2, 3, and 4, the result is increasing. This is our f prime of x, 2x plus 2. Substitute natin. What if you are going to choose negative 1? Okay? Yun yung kasi hindi natin na-identify. So, for example, negative 1 plus 2. So, what is the result? 2 times negative 1 is negative 2 plus 2. The answer is 0. See? So, here, may problema. Pag -2, you get in decreasing. Pag 0 to 4, you get increasing. Pag -1 is 0. So, the answer for letter C is neither increasing nor decreasing. So, we're going to talk further about this 0 thing. Ganyan lang ka-easy to determine is it increasing or decreasing by choosing the value of x in between the open interval. Then before that, you need to derive first the given function. Then substitute mo yung napili mo na numbers in between or is an element of the open interval. So if the result is less than 0, you can say that that is decreasing. If the result is greater than 0, that is increasing. However, the same as in the case of letter C, you must observe and must be accurate with this one. I think kung kaya mo naman isolve, hindi naman masyadong malayo yung mga gaps, you can do that to make sure is it the pattern is increasing or constantly decreasing or constantly increasing. If not, you can have the neither. Okay? Now remark the value -1 on our previous example here, diba, yung -1, serves as, so ito na, natawag siyang critical number. For the function, ano yung function natin? X squared plus 2x. So, now we're going to talk about more about critical numbers. Now, the next definition, 2.5.2, states that, talks about critical number of a function. A number C in the domain, take note ha, yung number C in the domain. Pag hindi siya kasali sa domain, then automatic that is not a critical number. A number C in the domain of a function f is said to be a critical number of f if either, saan sa dalawang ito pwede siyang masasabi natin that is a critical number. But take note, must be in the domain of a function f. So either f prime of C is equal to 0 or f prime of C does not exist. In our previous example, we have f prime of -1, which is our C, for example. It is equal to 0, and -1 is part of the domain. Therefore, -1 is the critical number of this function, x squared plus 2x. Now, this is the illustration. So, the following graphs illustrate that the indicated points have abscesses that are considered critical numbers. So, from the graph alone, we can determine kung nasa na yung si critical number. In this one, according to the definition of the book, the function in this graph has a horizontal tangent line. So, imagine mo na lang may horizontal tangent line dyan. And the point of tangency, for example, that is indicate what the 0 point or what we call the critical number here. And the next graph, the function in this graph has a cups of the indicated point, meaning that the derivative of the function at the point does not exist. Kanina we got 0. Here we have the does not exist. And that is our critical number since this part is a part of the domain of the function. Next one, the point in the graph of f of x is equal to the cube of x minus c, represent an abscissa that serves a critical number. Here, as you observe, we can see that this part or such number letter c is a critical number because it is part of the domain of the function. And then we get here, which is equal to 0. So serves as our critical number. But in this last graph, the function f of x is equal to 1 over x with the derivative of this function, which is equal to -1 over x squared. We have here does not exist or does not have a critical number, rather at 0. So bisan pa nga ang derivative niya does not exist, according to the definition 2.5.2, it must be either 0 or does not exist. Here we have the does not exist, but the problem is that domain domain po ng function ng f of x equal to 1 over x, wala po dun si 0. So, in short, yung critical number na considered unta is not a critical number because 0 is not a domain of the function compared to the previous graphs. So let's have some examples to determine the critical numbers for each function. So we have four. First one, f of x is equal to x cubed minus 3x squared. So first is we need to find the derivative of the given function. So we know that derivative of this one is equal to 3x squared minus 6x, right? Applying the previous lesson. Okay. Tapos, kung meron na tayo nito, equate natin equals to 0. This is the default one. Equate natin equals to 0. So, matapos makuha yung derivative, equate natin yan equals 0. Since we need to find the critical numbers. And then here, we can have the common, which is 3x. So, we get x minus 2 equals 0. Right? So now we have two rows. 3x equals 0. Tapos x minus 2 equals 0. So here our x is equal to 0. And here our x is equal to 2. So 0 and 2 are our critical numbers. Okay? So, inanara kadali to determine the critical numbers. So, first is to derive the given function. And then, equate mo na yung result, equate mo sa 0. Then, take the factors and then find the x. So, here we have two results. X equals 0 and x equals 2. So, that is our critical numbers. Next is f of x is equal to x over x squared plus 4. First is we need to derive this one. So applying the rule of the division of the derivative, we have x squared plus 4. I-square natin yan. Then copy natin to. And then what is the derivative of x? It is 1. Pag variable lang. Then x. Then derivative of x squared plus 4, that is 2x. Tama. Equals. So simplify. We got x squared plus 4 minus 2x squared over the square of x squared plus 4. X squared minus 2x squared. We got 4 minus x squared over the square of x squared plus 4. So that is the final answer. Equate natin sa 0. So what is the result now? Cross multiply natin, it will become 0. So 4 minus x squared equals 0 na lang. Right? And then, transfer natin. And then, ano next? Squared natin. So, our x now is 2. Since square yan, so positive and negative. So, we have two answers for critical. X is equal to positive 2 and x is equal to negative 2. These are what we call critical numbers. That is so easy to determine the critical numbers. So, ulitin ko, first is to determine first the derivative and then equate mo sa 0, then find the value of x. And the result will be our critical numbers. Next, determine the critical numbers of f of x is equal to 2 x over x squared minus 1. So first is find the derivative of our f of x. So this is division. So square natin yung denominator based on the rule. Then x squared minus 1. What is the derivative of 2x? That is 2. Minus 2x. Now what is the derivative of x squared minus 1? That is 2x. Simplify. We got 2x squared minus 2 minus 4x squared all over the square of x squared minus 1. Right? So we have negative 2 minus 2x squared over the square of x squared minus 1. That is our derivative. So equate natin sa 0. Negative 2 minus 2x squared all over the square of x squared minus 1 equals 0. So the result is negative 2 minus 2x squared equals 0. Now how we are going to get the value of x? So using the skills in doing the algebra, you can have this 1 divided by 2. So the remaining is negative 1 is equal to x squared. Now if you are going to the square of negative 1, the result can have negative 1 or 1. Although 1 and negative 1 make a derivative of f undefined, they cannot be considered a critical numbers because they are not in the domain of f. So here, f has no critical numbers. Because if you are going to substitute here 1, you get undefined, right? So for example, 1. 2 times 1 is 2 over 1 squared minus 1, 0. So 2 over 0, that is undefined. If negative 1 also, the same, we have negative 2 over 0 undefined. However, negative 1 and 1 is not part of the domain of our function. Therefore, our f has no critical numbers. The next, determine the critical numbers for f of x is equal to cosine x. So the derivative of this one is equal to negative sine x. Right? And equate natin sa 0, negative sine x equals 0. Take note in this transcendental, x is equal to k times r pi for every integer k. So, sir, ano yung critical numbers nito? So, we have what? We have infinitely many critical numbers. So, may naka-unique for transcendental. So, matod pa sa atong unang gingon ganina, there is a working application how we are going to get the optimization of a certain number, but it is only working until quadratic. But for greater number of exponents and even transcendental, it will not work. That's why we have now an improvement in doing this one using the different theorems and definition. And in this case, we got an infinitely many critical numbers. Meaning, yung f nito, f of x equals cosine x, it can be yung critical number niya is equal to 0 or undefined. So, there's a lot. That's why infinitely many critical numbers. Take note that the critical numbers, if there are any, subdivide the domain into a finite number. So, for example, in our case, sa last example natin, we have many critical numbers, infinitely many. So, we can subdivide that one to the domain into a finite number of subintervals where the increasing or decreasing nature of the function can be determined. So, as you observed for sa previous lesson for pre-calculus, we can in the graph for sine and cosine na nag-wave sila, and we can determine kailan sila nag-i-increase, kailan sila nag-i-decrease. Now, the same as we can subdivide this one into the domain to get the finite number of subintervals where we can get the increasing or decreasing nature of the function. So that's all for the part 1 in the application of derivatives. So first, derivatives optimization. So we're just talking about only increasing or decreasing functions and then the critical numbers.